I envision a future in which our loved ones with Alzheimer's disease can have a device implanted that helps their brain to remember, much the same way that a cardiac pacemaker helps the heart to maintain its rhythm. Today, my goal is to share a reason to be hopeful that this future might be closer than you think. I believe that the next few decades will offer new therapies for those with memory impairment, one of which I've been working to develop in a lab just down the street. I'd like to start with an iceberg, something evident on the surface with much greater depth underneath. All of our memories exist in here, in our brains. All of the richness of what we experience results from a complex storm of electrical activity emanating from the 3 pounds of tissue living upstairs in the bony envelope of your skull. This complex storm of electrical activity is the biological basis of our memories. This biological perspective isn't new. It's long been how neuroscientists like myself think about the brain and its complex operations. But distilling the richness of our experiences down to the same biological code presents an interesting and important question. If memories are all made of the same physical stuff, why is it that we remember certain experiences over others? Why is it that certain memories persist for years or even decades, whereas we often misremember the details of what's happened just earlier this week? Many of us in the room have so-called flashbulb memories of highly vivid emotional experiences that seem to last a lifetime. When I was a sophomore in college, I formed one of these memories that would change the course of my life. This particular experience began with a phone call in the middle of the night during an otherwise uneventful summer. The phone call came from someone very close to me, someone I knew well. I remember the confusion I felt on the phone as this person urgently insisted I come over to help him. I remember this confusion only growing as, when I got there, he recounted this strange and unbelievable story of what had been happening to him. But most of all, I remember the sadness that I felt when I realized that what I was witnessing was a major psychotic episode, one that would come to herald the changes in our relationship for years to come. This experience is what set me on a path to neuroscience. It's what caused me to think deeply about how the brain functions and what causes it to break down. I've since learned why it is that memories like this last. And it seems like one particular area of the brain, deep within the center, about the size and shape of an almond, plays an outsized role. This area, the focus of my research, is the amygdala. The amygdala is a small but influential part of a widespread network of brain areas involved in learning and memory. We know from over 50 years of research that the amygdala functions as a sort of alarm system that tags something highly emotional as worth remembering. So regardless of the content or the context, when your amygdala is highly active, you're more likely to form these long-lasting memories. Now, I mentioned the amygdala and its special role in memory because as an MD PhD student, my focus is on taking ideas from the bench to the bedside, moving what we learn about from the brain in the lab to new therapies that can help those with memory disorders. Few things are more terrifying than the idea of losing your memory. And for many, this isn't an abstract idea at all. It's a daily reality. Over 500,000 cases of Alzheimer's disease will be diagnosed this year alone. This amounts to 1 new diagnosis for every minute that passes. And few treatments exist for these individuals, none of which are capable of staving off the inevitable cognitive decline associated with this progressive neurodegenerative condition. In our lab, we record and stimulate the human brain directly in order to understand its function. These brains belong to patients who've recently undergone neurosurgery because they have epilepsy that's difficult to manage with medication. For these patients, surgery is really a treatment of last resort. where the goal is to remove the areas of the brain causing seizures, a procedure which we carried. In order to find where these seizures are coming from, neurosurgeons implant several electrodes that resemble angel hair pasta directly into the brains of these patients. Then, over a period of days to weeks, these patients rest in the hospital waiting for these seizures to occur. And what this downtime presents to someone like me is a unique opportunity. An opportunity to work with an exceptional group of individuals willing to donate some of their time in the service of benefiting others. Using these same electrodes implanted for clinical monitoring, we can observe memories being formed in the brain in real time. We can show these patients a series of images and then later look at their brain activity as they retrieve those same images from memory. But what's most exciting to someone like me is that with these very same electrodes, we're also able to deliver electrical stimulation in order to influence how the brain functions. I mentioned before that the brain is an electrical organ. The brain takes complex information from your senses and converts that to an electrical code that transmits information between brain areas. So given what we know about the role of the amygdala in memory, we reason that we could commandeer the same innate alarm system in order to enhance memory and tag any sort of experience with the importance of something otherwise very meaningful. So for the patients who volunteer for our research, we show them a series of images, we stimulate their brain during some of those images, and then we test their memory. What we've seen from this approach is very promising. Most of the patients that we work with show an enhanced ability to remember the images we stimulated over the images which we did not. And although this is early, we have a long way to go before methods like this become mainstream, our results provide some early evidence that creative and innovative approaches to studying memory might offer fertile grounds for new discoveries and novel therapies. Indeed, it's my hope that our research will go on to influence the design and development of new devices that stimulate the brain in order to restore its function. What we remember and experience is unique to each of us. We are the sum of these memories. What I'd like you to take away from my talk tonight is that our memories are worth preserving, and new research is actively underway, which might eventually help us do just that.